Okay, now that we've de-rats nested this, we're going to go ahead and route it. Now, there is an auto route feature, but the reality is industry people almost never use it. There's some issues with it, and honestly, when you're routing an industry, you're actually having to be more concerned about having traces too close to each other and other things of that nature, because that will create capacitors and all sorts of other things. But for our purposes, we can kind of ignore some of those effects because of the circuits that we're doing. So first off, you kind of want to maybe click away. You can see it says last pick and no element find. You want to make sure you don't have an element selected. Like I've got one and it shows it down here being selected. I don't want to have anything selected. And then I'm going to go to route and then connect. Now, by the default, it's on the top layer here. We don't want to be on the top layer. We want to do everything from the bottom layer. And that's because these are all what are called through-hole components, meaning that they're going to drill holes and then we'll solder them on the bottom side. The top, quite frankly, is what is done in industry more often, and many of you will probably do in your senior project. That's for like surface mounting, where you don't actually drill any holes. The chips are all mounted directly on the surface. But again, we're going to be doing bottom. Now, the alternate you can just leave at bottom. This would be if we're going to use vias, for instance. Now, by default, it has a line lock at 45 degrees, meaning that when I start doing things, it won't just let me do any angle. And you either want that at 45 or 90. Honestly, you don't really want it off. You want to have those line locked. That's a pretty standard thing to do. And then you simply start playing connect the dots. Now, if I click here, I'm just going to start here. And you can see I can move this thing here, but it has a yellow line telling me where I need to connect it. So I'm just going to do shortest path there and connect it up. Now I have this one, and you can see if I try to go through this line here, it's not going to let me. And so, of course, I can go over. Now, it's going to basically obey the rules we've set in there. And notice how close that is. Now, technically that's okay, but if you're going to solder this by hand, especially if you don't have great soldering skills, you'd be better off moving it a little bit further away. And if you move it further away, you can left click and force a turn. And so I can kind of force some turns here like this and just bring it up here. Now, the other thing I want to point out to you is notice this is labeled 0, and that's because it's 0 volts. That's ground. So I can kind of think, okay, this is going to be a ground here. And then we're just going to continue to play connect the dots. Now, here, let's do an oops on that. I'm going to connect this one right into here. Now notice I got to connect that one. Well, you can go, these components are just representing where the resistors are going to be. I can run a trace there. I mean, that's fine. I'm just going to solder here, and then I'll solder here. And then okay, well, I've got to get to that. Now, there's a couple ways that I could go in through here, or I could decide to go up and around. And it doesn't really matter at this point in this particular circuit. This does matter when you're doing complicated designs, but that, again, would be something you would learn more in industry. And then, again, just connect the dots here. Okay, where does this one go? It goes right there. Play connect the dots. Now, it gets pretty easy when we first start here, but it will get more complicated here. So now, notice this one is saying go up here, but it's also connected down here. So I'm going to actually, and notice that's my triangle output there. And then this one, see, I might have some bad layout choices here, because now I'm going to get myself in trouble here. And so if I see here, oh wait, where that resistor is, that's a bad idea. I'm going to do a cancel here, and I'm actually going to then, believe it or not, I'm going to pick that up. I'm going to go back to my components manually, place components manually, and I'm going to pick this resistor up and move it over here. So I moved that resistor, and there was that little red box that came up, and that's because I've got a component that's too close to it. And so I'm going to have to adjust a few things here. And I'm going to go ahead and move this out a little bit here. You got to kind of play around with it, and notice that that was ground there. So I'm going to go ahead, and I'm done placing them here, and close. And then what I would do here is simply go in, and you can't use the delete key. You have to right click and say delete, and then I would just go ahead and delete those traces. So now we still need to connect this up here, so we'll go back to click off the screen, and now I got to connect this back up, but we can see here I can just run this all the way over here. And now we're going to say, okay, well then I can connect up here to here, and this is ground. Now this can kind of connect, and maybe I can do something like that. And we have to keep playing. Now you might have to move things around even more. I'm just trying to show you how you do this. So you might have to end up doing this even more. So your assignment is going to be to actually do this layout and finish it, de-rat's nest it all, and it's not probably going to look like this, but you want to get the components as close together as you can, and you want to get them all lined up and get all the routes. Now I'm going to open a different file here and show you the next steps here. So let me open, I'm not going to save that. And let's see here. What do I want to go to? Just pulling up a different board here. Okay, so this one is one that I did for my brother here. And without going into, actually that's not the one I want here. Let's see, what is that one? Nope. Just a second, let me get one. I can't remember. Here it is. This one's okay. This is a 2-layer board, but that's fine. So this is actually a 2-layer board here. It's for an equalizer. Actually, I'm going to do this one more time. I've got so many different board files here that I'm just trying to find one here. Summer camp, power supply layout. That one will work good. Except I need one that's actually completed. Here we go. Power supply board. So this was actually a circuit here that we'll actually do this in the electronics lab, build something like this, where this is actually takes in wall power and puts out 9-volt DC. And this is a transformer. This is a 1-layer board, and you can see I made all the routes, and some of them I made a little bit thinner, like right in here, just to kind of get everything moving around and whatnot. So this is my layout here. Now once I have this layout here, I actually have to generate the information for the circuit board etcher to actually be able to etch all of the files or the information out of copper. So what I'm going to do here is I've got this here. I'm going to go to export, and there's 2 things we need to do. We're going to do export Gerber, and that creates the artwork for the etch layers. So we have bottom and top, and if I open bottom up, you can see it's got the etch bottom, the pin bottom, and the via bottom. Now we're not doing any vias, so that's not something that we need to worry about, but etch would be all of those traces. So that contains the information about how to trace out all those places. The pin bottom will tell you how to etch out around the pins, because there's always going to be copper that you etch out around those pins for the through-hole mounting. And so what I want to do is I want to select that, and then what I'm going to do is I'm going to create artwork. And it will create the artwork file here in a second. Usually goes a little bit quicker than this. said completing with warnings or errors, and that's fine. It's if you want to look through the file here, bottom created with warnings, artwork had warnings, and I don't even see, oh, DRC out of date on this layout. That just means we haven't done a design rule check. If I wanted to get rid of that error, I can show you how to do that. See how this is a little red down here with DRC? If I go to check DRC update, it now is green. And if I go to export Gerber now and do bottom, create work, that time it had no errors. Because I had done a DRC update. Basically, DRC stands for design rules. It makes sure that you haven't violated any design rules. And those are more advanced topics, but we did set up some of our design rules when we said the minimum line width, when we set the pad-to-pad spacing in the very beginning when we were doing these. Those are all design rules. Alright, so I've created the artwork for the etch layer. Now I have to create a drill file. I need to tell it where to drill. So we do nc drill. Now this is very important here. Make sure that auto tool select is checked, and then go into parameters and make sure down here at the bottom that enhanced Excelon format is checked. If those aren't checked, it won't export the file properly. It will still export it, it just won't be something that the machine that we have can read. So those have to be checked. And then you click on drill and it will say processing successfully completed. So just so you can see what comes with these, let me actually go and show you what we just generated here. So if we go to where these are stored, summer camp, wrong one, Dropbox cadence, summer camp, Allegro, you can see this bottom art file, and it was just created today. If you were to actually open it's just a text file. I'll open it, and basically it's got all these X and Y coordinates, information on how to do all of the traces, and I don't necessarily know how to read this, but it's basically, you can see X coordinate, Y coordinate, things of that nature. And then the drill file would be the name, which, what do we call this one here? 3-channel summer board. Let's just do by date modified. Power supply drill. So the drill file right here, again, we could open this, and I'll go ahead and open it. It's going to ask me what program to use. I won't always, but it's just a text file as well, so I'll just open it. And here you can see, and it actually gives you 1, 2, 3, 4. These are the different drill sizes, drill bits, and these are actually in inches, so like 0.0315 inches, things of that nature. This here is putting it in whole mils, 31.5, and it tells you how many quantity for T01. Oh, look, here's T01. Here's the X and Y coordinate on where it needs to go. Here's the X and Y coordinate for the next one. You know, and you can kind of see all the spacings out there. And it makes sense that a lot of the X and Y coordinates are the same because, of course, we're just drilling holes there. And so that's what those files look like, and that's what the machine would be setting in. So what I want you to turn in, and I'm going to create a place for you to turn it in on Blackboard. And actually, I'll go ahead and do that and pause the video and show you how to do that. Okay, so let me show you how I want you to turn these in here. So let me pull in Blackboard. I created a little assignment here. So layout, turn in the board file, bottom art, and drill file. So you'll click on the link here, layout, 20 points possible, attach files. Now you need to attach all 3 files. So I again will go into that Dropbox cadence, and then this was in the summer camp, Allegro, and then Power supply was the board. So I would put that file in. I would put the bottom file and then the drill file. And then I held the control key in to do it, but you need all three here. Don't do one at a time and hit submit. You have to do all three and then you click submit. Now each one of you should do this individually. This should not be a group lab that you do. This should be done individually. And then you click on the submit. Alright. Now at the end of the semester here in this lab, we will have time to actually create one of them, and this is one option for you to build. We'll have another one that we will design and build instead, but this will be one option for you to build, is this particular circuit.